So I'm Mike Rowe. I work with Frost Sullivan, where I'm the Vice President and Global Practice Leader of the Aerospace, Defence and Space Advisory Practice. My background was in the British military, and then I worked in the defence industry upon leaving and joined Frost 5 years ago. And it's an honour and a pleasure to be here. The aerospace and defence industry is facing a growing need to address sustainability concerns. That's the truth. And there's many ways it can do that. Some of the ideas in the defence industry that I've seen are improving the efficiency of the defence estate and the bases, transitioning to renewable heating, for example, also looking at switching to renewable power sources and installing carbon capture technology as it becomes more efficient and affordable. The other area defence can benefit, and aerospace, is the so-called dual-use technologies. So they can benefit from off-the-shelf, low-carbon technology that's being evolved in the non-other markets, non-defence, such as sustainable aviation fuel. The Royal Air Force, for example, already is using a percentage of that. Also, fuel cells, hydrogen fuel cells, and electric vehicles. It's interesting that the United States military is flying a Joby eVTOL, for example, to learn how that can assist it and using it for logistic purposes on an airfield. Frost has quite some deep knowledge on this. We did some work for the British Army. They are looking at alternative propulsion systems for their armoured vehicle fleet. There's not just the sustainability benefits, but also military benefits, such as being silent when moving and keeping the vehicle charged when the engine is switched off. I'll switch to aerospace. That's the purpose of the show. And when I say aerospace, that's airports, airlines, and the aircraft themselves. And they're facing a situation where demand for air travel is expected to grow rapidly, whilst the industry will also have to reduce carbon emissions between now and 2050 at the same time. And several companies are actively moving into this area, and we're seeing new technologies being brought in as the main way to meet that, coupled with the need to transform the way they operate to maximize the benefits of those technologies. These technologies can range from electrification of airports, greatly improved air traffic management, both in the air and on the ground, advances in runway lighting systems, plus measures to complement the take-up of sustainable aviation fuel, biofuel, such as avoiding contrails, which contribute greatly to global warming, and also hydrogen propulsion and hybrid propulsion, which will come first, as it will help gain safe flying hours to prove the technology first. But fundamental is the experience and appreciation of the end customer, the traveller. So some recent examples in the Middle East is that Archer Aviation just announced a partnership with Adeo and Mubadala to start electric air taxis in the UAE from 2026. And in the area of sustainable aviation fuel, Emirates Airlines have expanded their collaboration with Nestle for 3 million gallons of sustainable aviation fuel in the 2024 to 2025 period. So we are seeing some committed actions by key players towards decarbonisation. Whilst they may be seen as small steps in the larger scheme of things, it is definitely progress. Certainly. Urban air mobility, also called advanced airborne mobility, AAM, refers to the safe and efficient aviation systems with commercial, private, and military applications. And UAM refers to their use in dense urban areas, currently served primarily by helicopters, which do service areas, but inefficiently. But that is still the one to look at when you're considering the use of eVTOLs, electrical, vertical, takeoff and landing aircraft. Automated aircraft are still in development, and that is where the critical path lies for making a profitable business out of urban air mobility. As long as you need pilots and are constrained to current takeoff and landing points, the market will not grow as fast as some would have us believe. So the key fact is the UAM development and future adoption will require significant infrastructure investment, safety nets, regulations, air traffic management, and public acceptance. And so we will see some kind of trophy use, tourism. I think you will see it in UAE first, and also probably at NEOM project in Saudi. But it's the fully autonomous aircraft that will significantly reduce labor costs for companies. And for a typical airline, that is one of the highest expenditure items. That autonomous flight is the thing to look at when you're looking to invest. So the production and investment in smaller aircraft, such as eVTOLs, will pave the way for broader UAM adoption. And there's also the current vision for VPorts, or vertical takeoff and landing airports, to circle an urban area and then integrate with the kind of final mile public transport solutions, such as taxis and buses and trains. We did do a survey in 2020 of 100 cities with 5,000 questionnaires going out to end users and stakeholders. And back then, we correctly predicted that UAE will be the first to legalize urban air mobility aircraft. We also predicted that the use of UAM would probably start in the transport of cargo at scale rather than people. And that cargo flying will generate the safe flying hours to enable people to be lifted at scale and eventually for the pilots to be replaced. And it's only once that happens, I think, you'll really see UAMs take off. The space industry has been growing rapidly in recent years, with total annual investment reaching more than 10 billion, having been at 300 million in 2012. So it's moving at pace, and we're seeing big market leaders like Elon Musk's Starlink. Challenges include still supply chain disruptions, having to develop space-grade products into that market. There's regulatory requirements. The biggest constraint at the moment, as I'm aware of, is the ability to launch. There's still too few launch sites available, and that's been shared with me by many stakeholders in the industry. Other disruptors are the fact that the market is evolving very quickly, but there are long product cycles. So there's a lot of risk in production. Cybersecurity is increasingly a factor, and the need for digital transformation. All coupled with pressures to address environmental, social, and governance concerns, such as the continued growth of orbital debris. This debris is an area where we have produced a report for the show on the area, and it's probably one of the first areas which need to be addressed. It's difficult to evolve the space further until you're able to track and ascertain the health of objects in space and whether they are a threat or not. We looked at kind of the major trends and challenges in the sector, and they were Earth observation, satellite communication, navigation, sat-nav, the access to space, which I've mentioned about launch, space situational awareness, also called domain awareness if you include the weather, and obviously space exploration. And it was of note that the World Economic Forum has also identified sustainability as a key challenge for the space industry, and it focused on space debris being a critical challenge for the global community, endangering access to space and the benefits that it could bring. And it has, in fact, launched a space sustainability rating to address this challenge. Frost has done a lot of work in this area on a portal. We've looked at space mining growth opportunities, space traffic management, orbital space communication, space stations, and regional analysis, especially the Middle East, and the ongoing consolidation of the space industry. The growth of UAMs requires a wide range of collaborations between industry and regulators, infrastructure providers, communities, and other stakeholders, and governments especially. These collaborations are essential for ensuring that UAMs are integrated into the existing transportation system in a city in a way that is safe, profitable, and sustainable. And until they are, the constraints will hold them back. And the top constraints are the regulations. The UAM industry needs to work closely with regulators to develop a framework to ensure the safety, security, and privacy whilst it promotes its innovation and growth. Infrastructure, as I pointed out, without the necessary infrastructure such as vertiports, charging stations, air traffic management systems, ambitious OEM manufacturers of these eVTOLs aircraft will be unable to operate except in niche instances such as tourism or showcase events such as perhaps the next Olympics. Another constrainer is social values, as I like to call it. The acceptance of the paying customer is crucial to the success of any business model. Innovation is not enough, and the UAM, urban air mobility business cases must demonstrate the integration to the current fabric of mobility, such as metro and bus lines, in a way that's safe, efficient, and sustainable. And finally, downstream stakeholders, once the aircraft start flying, you're going to need the other accompanying infrastructure, if you will, to enable it to happen, such as insurance companies, financial institutions, and technology providers. These will all be essential in bringing what are currently concepts into fully operational services. The key factors, as we see it, for UAM adoption is focus on the restructuring of kind of the fleet strategy, being able to operate at low altitude, being able to operate in a congested airspace such as a city where it's very difficult for communications. You will see flying over city and coming down vertically, which is the attraction of eVTOLs, but flying through between buildings, it will be a major problem. So integrating the airspace to enable UAM operations is a key challenge. The other key challenge is regulatory approval for safe and efficient operations, and that is on a country-by-country basis. And without that regulatory approval, you will not be allowed to fly. So the countries which are taking the risk, especially those with less densely populated real estate, will lead the way for more densely populated countries. But there's still the challenge of technology adoption and the investment in appropriate research, and then the eventual route to success, if you will, for money at scale will be the autonomous aircraft being portrayed for commercial passenger and cargo operations. And that autonomy is the point at which we can have more aircraft flying to one pilot, which will enable revenue to be generated at scale, and things like continuous cargo supply, white vans of the air to operate. And there's some early good work being done by Dronamics, for example, with its cargo drone, the Black Swan. So the final point is collaboration is difficult in commercial businesses. Contracts compete and deliver at different speeds with different stakeholders. And in the gaps between, there's little money there to stitch them together to create something new and innovative. And that's the essential role where government steps in. And so the government investing in this future is fundamental to anything. We're very proud to be a knowledge partner for the show, and as an impartial and independent advisor, we hope our views and advice on various related issues such as space, urban mobility, airports, and drones will both add value to the event and raise awareness of the issues, both positive and constrained. So we see ourselves as being there to give useful business and technology intelligence to all tiers of supply and demand, and hope being there will raise awareness of our knowledge and support services, of course.